Something impossible just happened at CERN, and physicists are still trying to figure out what it means.
3 weeks ago, during what should have been a routine high-energy collision sequence at the Large Hadron Collider, multiple detection systems lit up with an alert no one had ever seen before. Inside the collision chamber, a stable dark region appeared.
No light.
No electromagnetic signature. But the mass reading said something was definitely there.
Even stranger, this invisible presence lasted for 2.3 seconds beyond the collision window. In particle physics, that's an eternity. Most exotic particles blink out in trillionths of a second. This one stayed put.
Why are scientists calling this terrifying? Because the instruments detected gravitational effects, localized spacetime distortion, as if an invisible sphere of pure mass had formed right inside the detector chamber.
Did CERN accidentally create and contain a bubble of dark matter? The stuff thought to make up 85% of our universe but never once touched by human hands?
Think of CERN's detection system as the most precise measurement facility on Earth. Atomic clocks line every beamline corridor.
These aren't your kitchen clocks.
They're synchronized down to picoseconds, trillionths of a second, because when protons smash together at 99.9% of the speed of light, even the tiniest timing error can ruin an experiment. On September 18, during collision sequence LHC 2024 DM7, something unprecedented happened. 5 separate atomic clocks registered a nanosecond scale offset, not milliseconds, not microseconds, nanoseconds.
For perspective, light travels less than a foot in that time.
Here's the chilling part, the clocks didn't drift randomly. They slowed down in perfect synchronization. Then, after 2.3 seconds, they all snapped back to normal as if nothing had happened.
This wasn't a software glitch. This was Einstein's relativity at work. Gravity literally warps time.
GPS satellites constantly adjust for this effect because Earth's gravity makes their clocks run differently than ours. So when multiple ultra-precise clocks slow down at the same moment, it means only one thing: something with significant mass appeared in that chamber.
Something with a gravitational field strong enough to bend time itself. CERN doesn't rely only on atomic clocks.
The facility also deploys portable gravimeters, devices so sensitive they can detect microgravitational changes from someone walking past the building.
We're talking variations smaller than 1/1000th of Earth's gravity.
During that same 2.3-second window, gravimeter unit GM47 caught something extraordinary, a minute deflection in the local gravity field.
The needle twitched downward, held its position, then snapped back to baseline.
Imagine a bowling ball sitting under a thick rug.
You can't see the ball, but you can feel the dip it creates when you walk across the rug. That's exactly what happened in the CERN chamber. An invisible mass created a gravitational dip that the instruments could feel. When we say bubble, we're not talking about soap bubbles. It's shorthand for a localized region behaving as if concentrated mass is present.
The clock slowed by nanoseconds.
Gravimeters registered deflections.
But optical cameras saw absolutely nothing.
That mismatch between invisible mass and visible emptiness is the heart of this story. Here's where things get even stranger.
While the atomic clocks were slipping and the gravity meters were twitching, something else was happening in CERN's service tunnels. This matches a theoretical framework gaining traction in dark matter research, the milli-charged particle hypothesis. Some physicists propose that dark sector particles carry tiny electric charges, not enough to interact strongly with normal matter but sufficient to nudge sensitive instruments. CERN's phaser experiment has been actively hunting for exactly these kinds of particles.
Localized dark matter interaction.
A dense clump of dark sector particles formed temporarily, warping time and gravity but leaving no electromagnetic tracks.
New exotic particle or field.
Something outside the standard model, perhaps a hidden sector field interacting briefly with our detectors.
Each scenario would be revolutionary. Even the mildest explanation would be the most direct experimental hint of dark matter ever detected. If confirmed, this isn't just another particle discovery.
It's a window into the missing 85% of the universe. Dark matter holds galaxies together.
It shapes cosmic structure. Yet we've never touched it.
If CERN's collision produced a dark matter bubble, it would be the first time humanity has manipulated the invisible scaffolding of the cosmos inside a laboratory. The Atlas and CMS collaborations are running their own independent reanalyses.
External labs are combing through the raw data.
More collision runs are being planned with upgraded timing systems and gravimeters.
If the effect is real, it will show up again. If it's not, it will fade into the noise.
Either way, the search is on. And this is where you, the viewer, come in. We're entering an era where AI, precision sensors, and high-energy physics are pushing against the edges of reality. Each new anomaly could be a glitch, or the first glimpse of a deeper layer of the universe.
3 weeks ago, nobody expected anything unusual. A standard high-energy collision run.
Then, for 2.3 seconds, time slowed, gravity dipped, and the electromagnetic environment shifted, all without a single visible particle track. Did CERN create a dark matter bubble? Did it momentarily bend the fabric of spacetime?
We don't know yet. But something happened.
Something measurable, repeatable, and unlike anything we've seen before. If you're fascinated by real mysteries backed by actual data, hit that subscribe button and smash like.
It genuinely helps us bring you more breakthrough discoveries like this one.
Because if this anomaly holds up under scrutiny, it could be the start of a whole new chapter in physics, and in our understanding of the universe itself. Thank you for watching my channel.